Hi, everybody. I want to give you this short video on working with categorical data so that you know how to respond to the question and the prompts. So we're looking at conditional probabilities, and we'll take a quick, brief look at responding to one of the questions. So in this situation, has modern technology changed the distribution of birthdays? With more babies being delivered by planned C-section, Mrs. McDonald's statistics class hypothesized that the day of the week distributions for births would be different for people born after 1993 compared to people born before 1980. After all, why would a doctor plan a C-section for the weekend? To investigate, they selected a random sample of people from both age categories and recorded the day of the week on which they were born. The results are shown in the table that follows, and the question is there convincing evidence that the distribution of birthdays has changed? So here's the data that was collected is people who were surveyed who were born before 1980. 12 people were born on Sunday, 12 on Monday, 14 on Tuesday, 12 on Wednesday, 7 on Thursday, 9 on Friday, and 11 on Saturday for a total of 77. You'll notice that there doesn't need to be equal numbers in the distribution. We're going to be looking at the relative frequencies of the number of people born on certain days. Remember, this is just random populations. This isn't have anything to do with people who might have been born under high risks. I mean, there might be some people included in that, but we're just looking at a random selection of the population. So correspondingly, after 1993, 9 were born on Sundays, 11 on Monday, 11 on Tuesday, 10 on Wednesday, 17 on Thursday, 9 on Friday, and 6 on Saturday. And looking at the distributions, we see some differences, but it's really hard to tell when you just look at numerical data how much things stand out. So what we're going to do is we're going to start working with the data, and the first thing that we're going to do is we're going to look at three things. Does the problem provide convincing evidence? And one of the first things that we want to do is calculate the conditional distribution for the birthdays of older people and younger people. And then we're going to make an appropriate graph for comparing the conditional distributions. And then we'll write a few sentences comparing the distributions of birthdays for each age group. So in calculating the conditional distributions, what we're going to do is we will take each day. So for example, we'll start with Sunday in the people who were born before 1980, and we'll divide that by the total number of people in the population who were born before 1980. So we're going to divide it by 77. And we're going to construct a table where we calculate that for each one. So the number of children or people who were born on Sunday before 1980 is 12 out of 77, and we're going to calculate the relative frequency as a decimal. So that's 0.16. And do likewise for all the other corresponding sets. You'll want to have a calculator and just take your time and do this. So when we start looking at the numbers, the relative frequencies, we get a little bit better idea because it's a standardized value. So what we're actually doing is comparing percentages, which allows us to compare two groups that have a different number in them pretty easily. The things that start to stand out is the difference in Thursdays is fairly significant. So once we're done with that, we're done with part A. We've calculated and drawn a table of the conditional distributions. So for part B, we're going to make an appropriate graph for comparing the conditional distributions. And so one of the best ways, since we have categorical data, is to make a comparative bar chart. So in this, you're going to want to sketch this, and the important things that you want to do is label each axis, and you want to label the categories that were selected there in a way that makes sense. And you want to scale the vertical axis, the relative frequency count. And so take a look at the graph in the blue. If you're using a pencil, you might want to shade it with diagonal lines shading upward. And then the red, the blue is for before 1980, and the red is for after 1993. And so you just want to shade them with a different type of marking on them. And make the graph look good on your diagram, but it doesn't have to be a drawn graph, just a sketch of a graph. So the next thing we want to do is write a few sentences comparing the distributions of birthdays. Now you'll notice that once we got to the visual part, we can really see the discrepancy, and that's the power of graphing statistics. Is visually we can make sense of things that we weren't able to make sense of before, or make observations anyway. So the first thing we want to do is we want to write a comparative statement. And the important thing to remember about a comparative statement is you must identify what is similar and what is different about the distributions. You can't identify just the similarities, and you can't identify just the differences. You have to identify both. And then you need to make an observation about what those differences or similarities might mean. So the first thing that we notice is that there was a higher proportion of older people born on Tuesday, Saturday, and Sunday, and a much higher proportion of younger people born on Thursday of all days. The proportions were similar for Monday, Wednesday, and Friday. And then here's the observation. So we said what was the same, we said what was different. We want to make some kind of observation. This supports the idea that doctors plan C-sections for convenient times. Maybe for them, maybe for their patients, who knows what. There was a smaller proportion of young people born on the weekend, and a much bigger proportion born on Thursday, possibly to avoid having their mothers go into labor on the weekend. So that's the complete process. If you have any questions, you can ask me about this in class. Thanks.